Okay, so here I would like to give an example to better illustrate this, because this formula is sometimes confusing. It still continues to confuse me at times. So let's say we have a surface, okay, and we know that this is an irradiance of 100 units, okay. So let's say the irradiance here is 100 units, and let's say this surface receives light from a very narrow angle, okay, something like this. So compared, the angle between is something like, let's say for the example, 89 degrees, okay, so almost 90 degrees. So, the irradiance here is 100. So the irradiance basically caused by this ray of light coming from this direction is 100 units, okay. Now, how do we compute the radiance in this case? So L is going to be this 100 units divided by, okay, whatever this solid angle may be. Okay, let's keep it as dW. Okay, whatever this solid angle may be, and then we divide this by cos 89 degrees. Okay, so now you can think of like this is in the denominator and this is almost zero. Okay, so because this is almost zero, you are going to have a very large value. So this means that to cause an irradiance of 100 units, you must have a very large luminance or radiance, okay, if the radiance is coming from a very narrow angle. But if you have something like that, okay, again, irradiance is 100 units. And the light is this time coming like perpendicularly, okay, like parallel to the normal. In this case, you are going to compute like L here is going to be 100 divided by, again, let's say dW, whatever this dW is, and then cos 0 degrees. So it's going to be like 1, right? So this time, radiance is going to be smaller. So this is important to understand. This means that if I want to create a irradiance value of 100, okay, and I'm having the luminance is coming, the radiance is coming from a very narrow angle, it must be very high. But if the radiance is coming from a very perpendicular angle to the surface, okay, so more light, it can actually make more effect, more impact, your radiance needs to be smaller to have the same effect, okay. So now the important thing to note here is that to compute the radiance from irradiance, we divide by this term. But to do the opposite, to go in the opposite direction, if you want to compute the irradiance from radiance, you multiply the radiance with dW cos theta. Now, why am I writing this? Because now let's go back to our rendering equation. Okay, in the rendering equation, what do we have? We have L, okay, this is the incoming light. This is the result, reflected light. L, we have dW, okay, cos theta, and F, BRDF. So I have reordered things a little bit so that it's more clear. Okay, so what is this? This is the irradiance, okay, differential irradiance basically. It just means a small amount of irradiance. So this term actually is dE, okay. So what does it mean? Why is it dE? Because I have a surface here and I am computing the irradiance that falls on it from a particular direction indicated by this dW, okay? So from a particular direction, but nevertheless this part represents the incident irradiance on the surface, okay? It's a differential small irradiance, but it's irradiance. Now we multiply this irradiance term by the BRDF, F, okay? So what happens then? As a result, we sum these things for all different directions, and as a result, we obtain radiance. So BRDF is actually kind of like a converter. It takes irradiance and converts it to radiance, okay? So the unit of BRDF is therefore, so here you have LR, okay, so let's only focus on one specific direction, okay, let's get rid of the integral. LR is equal to dE times F, okay, so what is F? F is L, let's also drop the subscripts, L divided by dE, okay. So what do we obtain here? If we write our definitions, L is, what was L equal to? It was equal to dE divided by dA cos theta divided by, this is dE. Okay, so this is going to give us, these will cancel out, 1 over dA cos, I'm sorry, I'm writing this wrong. So this is dW, okay? So 1 over dW cos theta, okay? So what kind of a unit this should have? Now this cos theta is unitless basically, right? It's just some number. But dW is a solid angle, okay? It's a differential solid angle. And the unit of solid angle is steradians, okay? Steradians. Remember, the full sphere is equal to 4 pi steradians. So this is steradians. Okay, so the unit of BRDF is going to be then 1 over steradians.